Thanks. Thanks again for being here. Hopefully, I can give you some of my research on this topic. Like I said, I'm standing between you and the mixer, so I want to make this quick. And in the interest of times, because we started a little late, feel free to stop and ask questions as we go along. If the answer is going to be lengthy, then maybe we can talk offline after the presentation. So today, I just wanted to quickly cover what we're seeing from edge computing and specifically the convergence of IT and OT and how OpenStack can help in this situation. My name is Ashish Nadkarni. I cover computing platforms research at IDC. IDC is a market research firm, so some of you might have heard of IDC, some of you may not have heard. We are not the actual doers, but we track the market. So much of this research is based on what I've talking to users, talking to vendors, seeing the market trends. So let's get on with the journey. So the session objectives, if you guys are familiar, I'm going to skip this in the interest of time. So IoT and edge get talked about interchangeably, and so today I'm going to talk about edge computing without really talking about the Internet of Things, but know that many of the edge computing use cases are born and kind of bred by the Internet of Things, connected devices, in other words. We have the core, which is the data center, as many of you might call it, your cloud, your private cloud, your public cloud. Now, there are some vendors who will tell you that the core is not the cloud. That's a subject of another discussion, but for now, we'll assume that the core is your cloud, your primary location where all the data lives, where all the computing happens, and where essentially your mission-critical applications live as well. Pre-IoT, much of the edge, as we knew it, was also called remote office, branch office, things that were outside of the main data center. I think it's best to reclassify or recast it as what is called as the IT edge. And what that means is much of the activities that happen in this edge are still within the purview of IT, and IT essentially owns the sort of the governance and everything that goes on in that tier, if you will. But the newer OT edge that we don't talk about much these days, but in the context of connected devices, in the context of Internet of Things, it's becoming more and more relevant, is what is known as the OT edge. Now, OT has been typically separate from IT, but we're seeing that those two sort of parallel worlds are converging. And what it is leading to is this notion of an intelligent edge. The intelligent edge being where IT and OT activities are converged, and basically the data that they collect is converged, and the analytics of that data is also converged. Now, some of the vendors and industry alliances are also calling the whole stack as a fog. So there's this alliance for fog computing. Again, this is not something I want to get into now, but you're happy to talk about fog. But fog computing is sort of the end-to-end structure of compute as it pertains to IT and OT edge combined. So why do we want to talk about the intelligent edge, and why is OpenStack relevant here? There are three principal challenges where I think OpenStack can help. The first is that the OT stack at the edge is becoming increasingly complex. Now, it used to be that in the olden days, or in the sort of the manufacturing era, OT was pretty much a standalone activity, and many of the devices that were connected were isolated from the internet. The data they collected was pretty much ephemeral and very much tactical in nature. Much of the business decisions were independent of it. But these days, that OT stack is becoming increasingly complex. The second is that the data center technologies themselves are getting pushed to the edge. No longer are people saying, if I'm running my accelerated compute, or if I'm running my multi-silicon compute, or any of the data center stuff is going to be restricted to the core. I'm going to push it to the edge. And the reason for that is the data that is generated at the edge needs to be analyzed in time at the edge, and you cannot just wait for it to be backhauled. Sometimes connectivity might be a challenge, and so you cannot really wait for the data to be backhauled, analyzed, and then the intelligence pushed out. It's too late by then. The third one is that your IT, OT, and CT technologies are converging. What that means is that the infrastructure that runs the applications for IT and OT and for what it is worth, CT, is common, right? So the infrastructure being common means that all of these applications run on the same platform. And so you need to think about them in a holistic way, not just as independent point products or point solutions. And so one theory here, and this is more of a sort of a test that we have to do with OpenStack, is to see if OpenStack can be the platform that can provide the common orchestration, provisioning, and automation layer for the intelligent edge, independent of whether the application is an OT application, is it a CT application, or an IT application. I know that there is the notion that IT and OT is pretty much all set with respect to the edge, but what it is not yet proven is the OT side of it. And so we'll talk about some of the things that could be done and what are the things that are changing on the OT side where OpenStack can help. So the first one is that the OT stack at the edge is increasingly complex. So if you think about some of the applications and the activities that are happening at the edge, these are activities that you would have never thought about in the context of OT a few years ago. So things like AI and machine learning in the context of OT, things like predictive maintenance in the context of OT, asset performance, being able to do real-time analytics on data that is collected by the OT, control and data acquisition solutions, human-machine interface, historian. All of these activities are relatively new, or in the context of IT, they're relatively new. So the OT stack, being complex, no longer can be handled by a set of folks in a standalone fashion. And you add to that the fact that businesses are pursuing a tiered application strategy. So there's a lot of focus on cloud-native apps, even for OT. So you have, and this was a survey we put together this year, and both the fact that you have applications that are being developed for core and edge, as well as multi-source data collection. So data is being collected from different locations, different solutions, is a cause for concern, especially at the OT, because now the data collection mechanisms and the data analysis is no longer a simple, straightforward thing. The second is data center technologies are being pushed to the edge. So there are three key ones that I want to talk about. The first is heterogeneous computing. This is the ability to have data center-grade silicon, not just x86, but things like Power, things like data center ARM, all of these systems built with these silicon being pushed to the edge. The second is accelerated computing. So a lot of people are using GPUs, they're using FPGAs, multi-core processors to be used as specific technologies for AI and machine learning algorithms, not at the core, but at the edge. And then the final one is composable infrastructure, being able to compose infrastructure from disparate or discrete resource pools and construct a fully autonomous system on the fly. So it's all being done in software, but there is a lot of work being done on the hardware side. So Intel RSD as an example, where you can compose solutions on demand, even at the edge. So the first is heterogeneous. What it is basically moving away from a monolithic sort of x86 only computing paradigm to having a matching of workload to the silicon. So regardless of where the code is run, it automatically kind of examines the type of silicon and adjusts itself. So you're sort of taking the workload and matching it to the type of silicon or vice versa. The second is silicon adapted. So you're automatically, thanks to containerizations, thanks to VMs, you can automatically adapt to the type of compute and use the right type of compute for the model that suits best from a platform side. And then the final one is, and this is some ways away, but you're already hearing quantum computing being introduced as a way to analyze certain types of data sets that are too huge to be analyzed by classical computing. So it's all about compressing your time to value. And edge is not exempt from the time to value equation. So if you are, in fact, collecting data at the edge, you have to be able to analyze it in a fast fashion using data center technologies like acceleration at the edge. And the environmental conditions at the edge are not often conducive to these data center technologies being run there. So for example, you might not have power and cooling available for running, say, GPUs that tend to get hot or need a lot of cooling to keep them at optimum temperature. So talking about accelerated computing, we have seen a lot of demand for acceleration, not just at the core where it is pretty widely deployed, but also at the edge. So not only are people deploying things like all-flash arrays and server-based PCIe flash, but they also are demanding systems that can incorporate GPUs and FPGAs in the system itself. The equation of sort of looking at acceleration, if you are interested, we can talk offline. But we have been doing a lot of research on acceleration, and this is sort of a quick stab at the taxonomy. So if you think about it, it's no longer just plopping an accelerator in the server and being done with it. You have different types of accelerators. You have different types of connectivity from the accelerator to the CPU. You have different types of form factors to deal with. And then, of course, you have different types of memory that go with it. So clearly, these are all design factors that go into the edge. And depending on what kind of workload you're running, you might have a very unique situation to deal with. But nevertheless, it is an important thing. The third area is composable infrastructure. Now, truth be told, composable infrastructure is not there yet. What we know of composable today is sort of the next generation of hypervisor. But in reality, what it is in a sort of a technical roadmap-ish kind of way, it is the ability to take disparate resources and layer on a on-demand structure on top of it so that you can take those resources and create a fully autonomous system. And so if I build this out, at the end of the day, you have the ability to take IoT-specific apps, edge apps, and use the software to create a platform that is mated to your workload. So if your workload requires heavy computation, then your composed solution is compute heavy. If your workload requires a lot of data, then your composed solution is disk heavy or flash heavy. If you need acceleration, then you can add acceleration. Again, today, a lot of this work is software-driven, but it is imaginable that within the next couple of years, much of this will be hardware and software, and the edge will also be a location where you can place these solutions because you'd be doing a lot of these activities at the edge. So the composable infrastructure part today, like I was saying, I just sort of build it out. People talk about hyper-converged at the edge today, and that's where things are. So we are in a sort of a partial state today. But like I said, in a couple of years, you will see a lot more in terms of composability. All right, so the third topic is the IT, OT, and CT convergence. I'm going to talk more about the IT and OT convergence, but know that edge computing is all about the convergence of IT, OT, and CT, so you wouldn't have a complete conversation without talking about CT. Now, CT, a lot of times people talk about is mobile, 5G, and a lot of the sort of the networking specific technologies. They cannot be talked about independently. They have to be talked about in the context of IT and OT. And so in this presentation, I'll focus on the lower two, which is the IT and OT part, not so much on the CT side. So there is a notion, and it's a conversation around software-defined OT. Now, if you look at the old way of doing things, much of OT was a very vertically integrated stack with proprietary hardware, proprietary data control, data acquisition and control software, and the OT apps that sat with it. It was a very siloed operation. Now, as with all things in the data center, the OT side of it is undergoing a change as well. It's no longer feasible to develop, proprietary hardware stacks and vertically integrated software stacks. People are moving to industry standard hardware and sort of moving their apps to be more software defined in nature. And again, previously, the only conduit through which OT apps could interact with IT apps was through the software layer at the data level. There was no connection at the hardware side. And that's a very inefficient way of operating, especially when you want the two sides to exchange information, do the analytics, and then transfer the information. So the software-defined OT side is pretty straightforward. You have a standardized, industry-standard hardware platform. You have the OT hardware that's connected to that hardware platform. And then, of course, you have virtualization, whether it's VMs or containers, that enables you to run IT apps and OT apps alongside each other. And then what you get out of it is this combined business intelligence layer at the edge, without having to go through any kind of translation layer, without having to go through any kind of a matching layer, if you will. It's a sort of a combined approach, and this approach is known as software-defined OT. So what we have seen is the emergence of edge gateways. Many times these are called IoT gateways. Now, the market for IoT gateways today is very fragmented, but we have tried to make sense of it and try to sort of put it under a common taxonomy. What that taxonomy looks like today is as follows. So you have, broadly speaking, two groups of devices. The first is called systems. These are what you would think of as systems that have grown up in the data center and are willing to be pulled out of the data center and with some minor modification run in the edge where the environmental conditions are not as brutal, but they are fairly challenging. So with minimum changes to the hardware design, you are able to run these data center grade systems outside of the data center. The second group of systems, or second group of devices, is what is called as gateways. Now, these are often fanless design, ruggedized. Many times they're very industry specific. And so, they often, look like boxes that can be, like literally embedded inside the industrial equipment they're part of. And, like I mentioned, the systems, they look more like rackable data center systems, except that those racks sometimes can be in a shipping container or a micro data center or what have you. Now, within systems, you have general purpose systems that are more IT-centric, and those are used for traditional IT edge applications. And then you have these new type of systems called converged IT and OT systems, where like I mentioned before, they're meant to run IT and OT apps together. And then here you have, on the OT side, you have all of the general purpose ones, network gateways, industry-specific gateways, consumer and home automation gateways, and the list goes on. And it's pretty fragmented here. And if you look at the market today, it's heavily skewed towards the gateway side. It's heavily skewed towards the industry-specific and network gateway side. But there's a shift happening, and people are moving towards the systems view just so that they can bring together the IT and OT space as much as possible. So with all of this background, switching gears to looking at, and if there was an OpenStack at the edge that controlled IT and OT efficiently, and don't get me wrong, we're not talking hypothetical here. There are companies who have deployed this and are fairly successful, but a lot of it is heavily customized. And what I'm suggesting here, or what I'm submitting to you, is that if you if you think about OpenStack as the control layer for IT and OT at the edge, then here are some of the sort of the design goals that would go with it. The first is, obviously remote provisioning, orchestration, and management of resources. Now, this kind of is a no-brainer because it is what OpenStack is all about. However, when you introduce OT gateways, you introduce converged IT and OT systems, it takes on a whole new meaning because these OT gateways are not your run-of-the-mill servers in the data center. These are very specific boxes with very specific operational parameters. And if you are, in fact, going to run containers on these OT gateways, or if you are going to run some kind of an app on the OT gateway, it has to be a very, it's a tuned resource. You cannot just run it the way you would run it in the data center. The same thing with converged IT and OT systems. You have to be careful how you can deploy these apps so that you cannot, you don't exceed the sort of the boundaries of what that system is able to do. The second is support for platform heterogeneity, acceleration, containerization, and connectivity at the edge. Now, the good thing about having OpenStack as a control layer is that it is independent of the silicon. So you are able to, in fact, run OpenStack services on ARM. You can run them on Power. You can run them on any other type of silicon that you would like to. But that key is being able to run the workload on the silicon, knowing and being aware of what kind of silicon is available to you at that particular edge. Acceleration, like I mentioned, I was talking to a customer today, and they said that acceleration is all about pinning resources. Now, at the edge, you don't have the luxury of pinning resources. So if all of your systems at the edge have some or the other form of acceleration, you can, in fact, use them in a fluid way to provision workloads that can, in fact, make use of GPUs, for example. Containerization, same thing. If you're running it as an OT resource inside containers, then you being able to push those containers to the edge is a fantastic way to keep your resource utilization lightweight. And then finally, connectivity, being able to use the OT, the connectivity hardware that is tied to the gateway itself is a crucial thing. Being able to use any of the IoT-specific protocols like Sigfox and Zigbee. The third one is a smartphone-like model. Now, this is more like a catalog, and I'll show you a sort of a design diagram that I took in the following slide. It's being able to drag and drop applications to the appropriate service tier. Now, you might have a very complicated edge design where your service tiers are not all the same, but being able to have a drag and drop approach where you can take the application in question and deploy it to the appropriate tier without having to worry about the underlying match, if you will, is crucial. And then, you have role-based access. Security is often taken for granted, and don't get me wrong, it's one of those things where unless you actively pay attention to it, unless you are always aware of what's going on in your system, you being able to have role-based access for an IoT is no different. You need to be able to make sure that these devices are secure, these gateways are secure, being able to drag and drop security layer mechanisms into the tier as well. And then finally, being able to manage data. So there is an underlying sentiment in here is that when you deploy a tier at the edge, you need to be able to control the data flow and being able to bring together all of these data sets in a secure way to the home office or to the control layer, to the core, and being able to use the right type of storage at the edge, provision the right type of storage at the edge, and ultimately make sure it's used to the right way. So with these goals in mind, kind of created a sort of a high-level design for OpenStack. So you have your core, so that's pretty clear. I think that you're going to have two different tiers. The first is the IT edge, which you could call as remote office, branch office. And here you have your Vertex, Dell Vertex-like systems, which are data center grade systems that are really, truly meant to take multiple workloads. And you can, in fact, run a 2-node, 3-node configuration for your IT edge. And here, it would be specifically IT only. But then you have your OT edge, where you have these two types of devices and being able to push out more and more containerized applications and being able to have, and I think there'll be two different catalogs that will be controlling these layers. So you have the IT catalog and you have the OT catalog. Largely for the time being, I think they'll be separate, but I could see a common catalog down the line that controls or has access to both of the IT and OT tiers. So with that, I wanted to sort of quickly end on a set of essential guidance, as we would say. So you have, the core. You want to make the most of the opportunity. So what would you do? If you are a vendor, then making sure that the systems that are essentially being built for analytics and machine learning and training, and then you have being able to use the right software partners so you can enable a quick ecosystem of partners with their applications. And then as a buyer or as a user, looking at a cloud-first model for your core would enable you to accelerate your edge and being able to manage your data flow and action control paradigms for compute at the core then effectively allows you to handle the system at the edge as well. And then moving to the edge, you have again, the same story for vendors, being able to partner with OT vendors like Honeywell and GE and Rockwell, being able to convert their applications to SDOT. So if you are, in fact, playing in the OpenStack ecosystem, then you can enable your customers to benefit from a catalog of SDOT applications. And then, of course, focusing on the convergence of IT and OT is crucial. And as a buyer, again, same thing about GRC, being able to extend your data governance to the edge. There's no right time to do it. Now is the time. So as you build your edge, focus on the GRC, the data governance piece, and then making sure that your edge comes under corporate-wide policies and processes and service levels. And here, OpenStack is crucial because then you can apply the policies that you would have defined efficiently and seamlessly to the right type of edge. And so I wanted to sort of thank you by hanging in there. Just a quick overview is what I intended to provide. I'm happy to take any questions either now or as I walk off the stage. And thanks again for your time, and have a great evening.